Hi, my name is Brandon Graisley. I'm a high school math teacher. We're going to talk today about how to use the inverses to the primary trig functions to find missing angles in right triangles. And remember, if the triangle is not a right triangle, you need a different process. This only works when you have a right triangle. So first of all, let's remember the primary trig functions or primary trig ratios: sine, cosine, and tangent. And you're going to need to remember how to find each of these. If you know the side lengths in a right triangle, you'll need to be able to use that, maybe that memory aid, SOHCAHTOA, for example. To find the sine of an angle, you use the opposite side length and divide it by the hypotenuse. So these are called the primary trig ratios or the primary trig functions. And you'll notice for each of these, the input is an angle. For example, we find sine of 30 degrees. And you can put that in brackets if you want. And that's the input, and then the output is a ratio. Sine of 30 is 1/2 or 0.5. That's just a number. So the output is a ratio, or you can just think of it as a number. Now for the inverses, they have slightly different notation. We put a little -1. It's not an exponent. That's the symbol we use for inverse. There are other ways to write this, but this is what's printed on your calculator, what most people use. So that says sine inverse, cos inverse, tan inverse. And for these ones, the input value is the ratio or the number, and the output value is the angle or an angle. So for example, if we were to use sine inverse of 1/2, we'll find that an answer is 30 degrees. Now, there's a trick with this, is that when we get into larger angles beyond 90 degrees, we have some challenges. We're not going to deal with that in this video, but you can look ahead, and those are some challenges that we're going to solve later on. So let's first look at an example of a right triangle. This one's probably familiar to you because it has nice side lengths. Let's call this one A, B, C. This side here, the AB side, which we would call little c, is 5. This one over here is 4, and this one's 3. This is one of those special triangles that works out to nice integer numbers all the way around. So our challenge here is to find the angles A and B. Find the measure of those angles. So that's the angle symbol. That's one of the ways that we can write this. We can find either one of them first. Once we have one, though, let's say we find A, to find B, we'll just have to use the fact that there are 180 degrees total in the triangle. So let's start by finding A. So this is going to be our reference angle. From this vertex here, from this corner, we can use any of the other 3 sides to help us find out what angle A is. Let me flip back up here to the SOHCAHTOA bit. For example, if I use the opposite side length and the hypotenuse side length, that will give me the sine ratio. Let's use that one. So the sine of angle A is the opposite side length. From A, that would be 4, divided by the hypotenuse side length. That's always 5 in this triangle. So I know the sine ratio, but I don't yet know the angle. So here, this is where the inverse function will be helpful. We can give it the ratio as an input value, and the output value will be an angle. So this is the ratio, and that becomes our new input for this relation. The inverse relation, sine inverse, takes that number, 4/5, and turns it into an angle. Let's grab a calculator. Look at this, a Casio FX 300ES Plus. I'm going to press Shift and Sine on that calculator. That gives me the sine inverse function, and I can type 4/5. I can use a fraction button or just divide. Looks like that. When I press enter, there's my answer that's in degrees, about 53.13 degrees. So that's an approximation. All right, cool. So we have an angle, and because this is a right triangle, these numbers that you get will always be the right numbers. With larger triangles, sometimes you have to do a little more work. So a little star here, that for now this is fine, but it becomes more complicated later with bigger triangles, with triangles that are not right and not acute. So for now we can just say this, angle A is 53.13 degrees approximately. Now to find angle B, as I mentioned, we can add up the different angles in here to get to 90. So we can do something like this. Angle A plus angle B plus angle C is 180 degrees. Sorry, I think I said 90 a second ago, 180. A is about 53.13. B we don't know yet. And C is exactly 90. So that's about 180. I put the approximately dot because this is an approximation. And so kind of rearranging all this and subtracting, I'm going to get, well, let me just grab the calculator, 180, subtract that 90, and subtract the other 53.13. Looks like about 36.87. So now we know both angle A and angle B. Now, just to back up for a moment, I could have used any of the three ratios. For example, I could have used tan with 4 and 3 to find angle A. And when I go to find angle B, this is a pretty fast way to do it, but you could also use a trig ratio like this one. There's nothing special about how we started with angle A here. So you can use trig ratios as long as you know 2 of the 3 sides in a triangle. You don't need all 3. And it has to be a right triangle for us to use this process. Okay, let's move on to another example where we don't know all 3 sides. So this triangle, we're going to call it DEF. Looks like this. And I don't know, let's say this side is 9 and this side is 6. Here's D, E, F. And in this case, I'm not just going to look for angles. I'm going to use this word, solve the triangle DEF. Solving means to find all angles and also find all side lengths. Now, if you don't already have all the side lengths, you're going to have to do some work. If you don't already have all the angles, you'll have to do some work. So in this case, let's talk about both of these. To find an angle, for example, finding angle E here, I can use these 2 sides with the appropriate trig ratio. I can do the same thing with D. If I want to find this side length, I could just use the Pythagorean theorem, and that's probably the safest thing to do because I'll get a nice exact answer. So let's start though by finding one of these angles. Let's go with angle E, let's say. So for angle E, what do I know? I know the opposite side length is 6, and this side length here, this is 9, the adjacent side length. The hypotenuse is this longer side over here. So I know the opposite and the adjacent side lengths. Let me just write down my memory aid again. So I want the ratio that uses the opposite side length and the adjacent side length, O and A, in my memory aid, which is right here. So I'm going to be using the tan ratio because I know these 2 values already. So I can find the missing tan ratio. So let's start with that. The tangent of angle E is the opposite side length, 6, divided by the adjacent side length, 9. All right, that's the ratio, to about 2/3, right? That's the ratio, and I can use the inverse to go backwards and find out what the angle must be. So let's write down this, tan inverse. You can just write 6/9 again, that's fine. Grab a calculator, shift on this calculator, tan inverse of 6/9. Looks like about 33.7. All right, cool. So that's an approximation for that angle there, because this is a right triangle. I can just say angle E is about that angle. Once again, on larger triangles, you won't be able to do this quite so quickly. The missing angle D, I can say is about 90 degrees minus 33.7. I don't even need to bring angle F into it. I can just work with these 2. And so I often grab a calculator for this because it's easy to make a boo-boo and be off by 1. especially when you're making a video. 56.3 degrees. Yeah, that sounds great. Okay, so D is approximately 56.3 degrees. We're almost there. We've solved for two angles, and we need to solve for the missing side. Pythagorean theorem is the best way to do this, although you could use one of the primary trig ratios. Using only the given information, we can find the hypotenuse using the Pythagorean theorem. So let's do that. I should maybe label that. I'm sorry. Let's go back up here. That'll be side little f because it is across from the vertex f. So we know from the Pythagorean theorem that f squared is going to be d squared plus e squared. D squared is 9 squared, and e squared is 6 squared. So that's 81 plus 36. Looks like 117. Okay, that is an interesting number. So to find f, we're going to take the square root of 117. We don't need a plus or minus here since we know this is going to be a positive number f. And on this calculator, which is a fantastic calculator, if I press the square root of 117, it'll simplify that for me to 3 root 13. So that is a nice exact answer with a mixed radical. And if you needed an approximation, once again on this calculator, this button right here, symbol to decimal, S to D, about 10.82. And so we've completed solving this triangle by finding the two missing angles and the one missing side. Okay, I hope that's helpful, and let me know if you have any questions.